Days are numbers, count the stars. It's the first line from a popular song, but the one after is more relevant. We can only see so far, it says, and it sums up perfectly our relationship with the stars that matter so much in our lives. What is a star in the first place? Well, a star is to the cosmos what a key player is to a team, a ball of energy just waiting to be unleashed. Stars are essentially bodies of hot gas arising within a nebula, which itself is simply a cloud of dust and gas within a galaxy. Most famous perhaps is the Eagle Nebula, with its stunning pillars of creation. Each nebula is like a cosmic kindergarten, from which bright young things are just bursting to escape. We call them stars. Suggestions are that 7 new stars form each year within our Milky Way alone. What trips the wire to kickstart the formation of a star? Usually it will be one of 3 events. The effect of an explosion from a nearby supernova, the nebulas moving through a particularly crowded pocket of space, or a flirtation with another passing star. At some stage, an area of high density within a nebula will resolve itself into a globule of gas and dust, which will then contract under the force of its own gravity. This condensing matter heats up. As the density increases, this protostar, that is to say the first iteration of the new heavenly body, starts spinning around a central axis. A new star exists in what scientists call hydrostatic equilibrium. The inward force of gravity is balanced by the outward pressure from the star's core. If there is sufficient matter, a nuclear reaction will take place, releasing a huge burst of energy, which must find its way from the new body's core to its surface. This process takes place over an enormous time span through a combination of radiation and convection. Next time you go to the beach, imagine trying to count every grain of sand, not just the ones you see, but all the others below. Then turn that idea on its head and imagine trying to count the stars, all those we see and those we don't. ESA's Gaia telescope is making that seemingly impossible task more like a reality. Its full map of the night sky is due for completion this year, but already preliminary data covering 2 million stars has been released, and the scientific world is very excited.
We want to measure a huge number of stars, where they are and how they are moving. So we can answer 2 questions at the same time. What is the structure of our galaxy, but also how it is evolving, or we can also look back in time. How did the stars move to come into the place where they are now?
The mission's technical measurement principle is there are 2 fields of view, 2 cameras basically looking at the sky at a very constant and fixed angle, and it rotates along the sky, so it traces a path along the stars. It then uses these measurements to determine the position of stars relative to each other, and then you can get to extreme accuracies also for the absolute position of these objects. The data comes down to the ESA antennas on the S-track network in Argentina, in Spain and in Australia. From there it goes to Darmstadt, who control the spacecraft, and then it goes to our central data processing hub near Madrid in Spain, which is an ESA center. And from there it goes to the data processing consortium, which then slices it up in different parts and processes this into science products.
Our first release will contain positions of 1 billion stars. So that will allow us to look, what does the night sky really look like when you would look at in random direction with a telescope which can see very faint stars. And a subset of 2 million stars, we will have the distance and the motion. So that is really the basis for astronomical studies. People can really look into details of these sources and study the behavior of the stars. And in addition, we have light curves for about 3,000 stars, so how they have been varying over time to analyze better the internal structure of these stars.
Eventually, it will plot the position and movement of 1 billion stars in our galaxy, the Milky Way. Astrometrists still have their work cut out, but thanks to Gaia, the job of counting the stars just got a whole lot easier.